So the sirens are running right now and the nuclear weapons are inbound, and you've got about 3 minutes till you're vaporized. Oh gosh, okay, that doesn't sound very good, does it? So the question is, what should you do in those 3 minutes? Well, a lot of people have thought about this problem, and some people have suggested, and not a bad idea actually, is to scribble down some notes for future generations to try and reinvent civilization. So maybe we can take that 20,000 year path to civilization and maybe make it 1/10 the length, maybe just 2,000 years. And so one suggestion for speed running civilization is to jot down the kinetic molecular theory of gases. And it turns out the kinetic molecular theory basically goes something like this. So molecular says that these gases are made of these little particles called molecules. Kinetic means that they are in constant motion. So you have a large number of molecules. And okay, so gases are made of trillions of them. They are in constant motion. So the kinetic is telling us about motion. And really the third thing is that the temperature of the gas is proportional to the motion. So at higher temperatures, we get more motion. At lower temperatures, we get less motion. And that's really it. So now you got about 2 minutes to enjoy yourself before you get vaporized. So what's going on here? So we can understand what causes pressure. So we said before, pressure is force over area. And if we want to ask ourselves what is causing the force, in kinetic molecular theory, the force is coming from the molecule striking the surface. And so right now you are being struck by molecules moving at several times the speed of sound. And that is causing a force everywhere that they go bump into your cheek or your eyebrow or your head or whatever it may be. That little impact causes a force, and if we divide it by the area, that is what gives rise to pressure. So that is really awesome. We can go ahead and we can understand things like Boyle's law. So Boyle's law said pressure is inversely proportional to volume, and so if we go ahead and we have a large volume, then our gas molecules, right, can kind of move around and bump off the walls. And every time they bump, right, they give rise to a pressure. And so a large volume here, we've got a fairly low pressure. And what happens if we lower the volume? Well, if we lower the volume, the molecules, right, are going to be striking the walls many more times in a given unit time. And so, you know, that one little molecule there that we started with, right, it kind of relaxingly hit the walls 3 times. But in the same time period, this guy's hit the wall like 7 or 8 times. So it's given rise to a much bigger pressure. And if you're staying inside now like you should be and avoiding the COVID scare, right, then you are probably bouncing off the walls a lot more. And so you're in that small volume, you're striking the walls more often and leading to an increase in pressure. So let's try and simulate Charles's law now. So Charles's law said volume is proportional to temperature. So if I go ahead and I take a little box there and I've got my little gas molecules and they are moving around and striking the wall. As I increase the temperature, as the temperature goes up, what's going to happen, right? Those molecules are moving more quickly. So they're moving more quickly. So in the same amount of time, right, they're going to bounce off more walls. And of course, if they bounce off more walls, then that would mean the pressure goes up. Now, if you're paying attention, right, that's Gay-Lussac's law. So what's the difference here between Charles's law and Gay-Lussac's law? Well, in Charles's law, right, pressure is supposed to be a constant. And so if we let pressure be a constant, so if the molecules are striking the wall and they would lead to an increase of pressure, we have to let the walls expand. And so as the walls expand now, right, so I've made my temperature go up, the molecules are striking the walls and they're pushing them back. And essentially what I can see now is that the volume has gone up. So as the pressure from the molecule striking the walls pushes the walls back, it makes them have a larger volume. So we can understand all our gas laws by actually sort of imagining what would the molecules do. And if you go on my website, you can play with the simulations, and they're a lot of fun. I'd encourage you to try it out.